Java supports mathematical operations, so you can add, subtract, divide, multiply, and get the modulo of numbers in your Java program. If you're unfamiliar with what modulo is, it's really just getting the remainder of a division. So 7 module 2 is really like saying, hey, if I divide 7 by 2, what would be my remainder? So over here is an example. We have 7 divided by 2. 2 goes into 7 3 times. We multiply 3 times 2 is 6. And we get a remainder of 1 here. Additionally, the order of priority of these expressions is as follows. First, we take parentheses into account, and then we move on to division, multiplication, and then subtraction and addition, reading left to right. So in this first variable, we have int x equals 3 plus 6 divided by 3 times 4. So it's first going to look at this 6 divided by 3 because from left to right, it's the first division. And this is, of course, going to give us 2. And then after we get to, it's going to do the multiplication by 4, which is going to give us 8. And then finally, it will add the 3. So you'll see we'll have a place in memory that's storing x. It'll do all this math for us and then store that value of 11 here. Following this, if we really wanted to force 3 plus 6 to be divided by 3 and then multiplied by 4, we can add parentheses. So we have this new variable y. We're putting parentheses, and we know parentheses takes priority. We know 6 plus 3 is 9, so then we're going to divide 9 by 3 because this is the next operation. That's going to give us 3, and then we're going to multiply by 4, which will give us 12. So now in memory, we will have a slot for y, and it will contain the value of 12. Now we have int z equals x plus y. So what this is going to do is it's going to grab whatever the answer to this is, and it's going to throw it into a variable z. So here we look up x. X is a variable. We check what the value of x is, and it's 11. So we're going to say 11 plus, same thing here with y, 12, and we will store that 23 in z. Now you might notice this next line is x equals 3, and we no longer have int. The reason for that is because we already declared x as a variable. We already said int x up here. You can only say int with a given name for a variable one time because you already declared it. So this is saying allocate a place in memory and call it x. Once you've allocated this place, you can't allocate it again with the same name. So here when we say x is 3, what we're really saying is we're going to reassign the value of x. So we're going to update x from 11 to 3. We are not going to declare it again because x already exists in our memory. So now you'll see that 11 will become 3. And now we have z equals x plus y plus z. So this code is going to get everything on the right side, add it, and then store it into z. So x currently is 3. It's no longer 11. We updated it here. So it's going to be 3 plus 12 plus whatever is in z. Now, I know it's a little confusing because you see z equals and then you see z again here. What's going to happen is it's going to do everything on the right-hand side of this assignment operation. So it's going to look for x currently, look for y currently, and look for what z is currently. And z is 23. So it's going to add 23 plus 12 plus 3 and then put that value into z. So you'll see that z will actually get updated after this executes. And now it'll be 38. There are compound operators, so this is sort of just an easier way of typing things. So if you see here on the left, we have z plus equals 1, z minus equals 5, z plus plus, z minus minus, z times equal 4, and z slash equals 8. So these are the same as saying all this stuff on the right. So z plus equals 1 is the same thing as saying z equals z plus 1. Same thing for minus, plus, plus, minus, minus. So this is really for whenever you have a variable and you have an assignment and you have that exact same variable on the other side of the assignment. So anytime you are updating a variable and using its current value within the assignment, this is when these compound operators will come into play. You don't need to use these because all of these on the right side work. These are just fun, quicker, easier ways to write what you see on the right.